this, since this is a dx ddx, we have our taking away 1 from the derivative from the power of. That's enough! You're all being assigned a project that is due at the end of the semester. Class dismissed.
In order for anybody to understand the mysteries of integrals, one must learn the rich history of its past. In the early years of calculus, finding the distance under a curve would be excruciating. Thanks to Eudoxus, who was a Greek philosopher, the method of exhaustion was created. This process required one to find the area by applying shapes to the signified area until the space was adequately filled. Unfortunately, people's attention spans are shorter than a goldfish's. Thus came 2 fine young fellows, Isaac Newton and Gottfried Wilhelm Leibniz. These 2 improved the integration process by discovering the fundamental theorem of calculus. What's the fundamental theorem of calculus, you may ask? I don't know. You figure it out. Okay, fine. Quoting Wikipedia, the fundamental theorem of calculus is a theorem that links the concepts of differentiating a function with the concept of integrating a function. That sounds like a lot of fun. But I don't care because this cool dude called George Frederick Bernhard Riemann created this sick process called Riemann sums. This operation requires the person doing the equation to segment their graph into rectangles and find the area of each one. The styles you could choose between are right, left, maximum, or minimum. But oh boy, back in the days of paper, Newton wrote small variables to indicate integration, and that's a big no-no. In comes Mr. Crumpet again with his mustache. Oh, I mean the integral sign. With this sign, you can signify the specific area between 2 points for the equation. When it comes to this thing, make sure you go from top to bottom, or B to A in this case. If you are greatly confused on what is taking place, let me give you a quick explanation of some things that may come in handy. To start things off, you need parabolas. You know, this thing, the squiggly thing. To get a load of these, hop on over to Desmos and type in x squared, x to the 4th, x to the 6th, x to the 8th, and so on. Now that you know what a parabola looks like, let's take a look at derivatives. I do not feel like explaining derivatives, so here's Khan to do it for me.
Welcome to the presentation on derivatives. I think you're going to find that this is when math starts to become a lot more fun than it was.
That's enough. Clearly, he's wrong. A derivative is pretty much the slope of a tangent line at any given point on the x-axis of a graph. With that out of the way, we can finally take a look at the Gratian celebration. I gotta introduce you to some of my friends. Here, we have Scott Gratian. He's a retired Major General for the United States. Here's Harry Gratian. He's a BBC broadcaster guy. And we also have Michael Gratian over here, and he's into moving children around. Ugh, it's Mr. Indefinite Integral. I didn't invite him, but I'll introduce you to him. When it comes to indefinite integrals, they are not as complicated as you think. This brings us back to derivatives. What's the point of jumping around the bush this time, eh? When it comes to derivatives, the process is pretty much self-explanatory once you know it. If we use x squared as an example, all you need to do is move this over here, throw it out the window, and smack your butt right back to math class because I am not your teacher. If you are so eager to learn the process of derivatives, go online and watch some videos. As far as I'm concerned,
we know how to take derivatives.
Continuing on, With derivatives already being a part of our knowledge, all we need to do is undo everything we did. Yep, we need to find the antiderivative. Pretty much do the process backwards and add c right after. That would make the entire equation 2x dx equals x squared plus c. This part of the equation is the indefinite integral, and this side is the antiderivative. So in a nutshell, the antiderivative is the indefinite integral. Now get out of my house. Who is it now? I gotta introduce you to Mr. Definite Integral. He is famous in this part of town. Regarding Mr. Definite, he is most recognizable by his personality. In non-video terms, his interval. The thing that separates him from his lower brother is the fact that he has start and end values. I do not want to scare you away from him, so let's start off with a simple math question. If we take a look at the equation, the definite integral has a lower bound of 1 and an upper bound of 2, 2x dx. The first step we need to take is to find the antiderivative, which would be x squared plus c. After that, apply the upper and lower sums to the equation and subtract the top from the bottom. That gives us an area of 3 units. Now, since we know the basics, time for something a little more difficult. Oh no! The world is being attacked by equations. We need to solve these equations before they grow too strong. Don't ask me why, but the plot calls for it. Hurry! Our time is running out. Use the knowledge to save the dream. There's an equation! If I remember correctly, Riemann sums are generally pretty easy. All that is required is 1 to find the area of the rectangles, and this equation has 6 over a distance of 2 on the x-axis. This graph is set up with the left Riemann style in mind. The first step requires us to add all of the heights together, and that would give us set 27. Divide that by 3 and the solution is 9 units. No time to rest, because there is another graph coming right around the corner. This time it is a right Riemann sum. Just like the last one, we need to find the height of each rectangle and multiply it times its base. Since there are 4 rectangles in a space of 2 units on the x-axis, each rectangle has a base of 0.5 units. The 4 heights are 5 over 4, 2, 13 over 4, and 5. Add these together to get 11.5. Multiply this by 0.5, and that gives us an answer of 5.75. Up next is an indefinite integral. For the equation x to the 4th power plus 3x minus 9, all we need to do is find the antiderivative of all the values. First off, the antiderivative of x to the 4th power is x to the 5th power divided by 5. Plus the antiderivative of 3x, which is 3x squared over 2, minus 9x plus c. Here comes a definite integral, the last question. Definite integrals are nearly identical to indefinite integrals. The last question is the definite integral of x cubed going from 4 to 2. To start the process, we need to find the derivative of x cubed, which is x to the 4th divided by 4. All we need to do now is apply each of the bounds to the equation. 4 to the power of 4 is 256, divided by 4 is 64. 2 to the power of 4 is 16, divided by 4 equals 4. 64 minus 4 equals 60.